today we're doing the Chem 85 lab of titration. So we get to play with acids and bases. Good stuff, right?
Excellent stuff. Very fun.
Stuff that you probably want to make sure you have your gloves on for.
Definitely.
And your glasses.
Make sure you're wearing your gloves and glasses, the designer glasses. And what we've got today is we have
Go ahead.
Oh, sorry.
No, I was going to say if you had any good stories about getting injured with acids or bases.
No.
No? Okay.
Yes, I do.
Oh, you do?
Yeah, I got 6 molar hydrochloric in my eye once.
Oh, and we're not using hydrochloric today.
No. But yeah, it was very fun. I got to put on the cyborg glasses at the hospital and all that kind of stuff, and went through a series of tests and almost lost my vision.
Not a good thing.
No, but it was an interesting process.
So that would be a good thing to tell the viewers at home. Make sure you're wearing your gloves and glasses.
Definitely make sure you're doing that. It was very painful. Okay, but what we've got today, sodium hydroxide. Okay, sodium hydroxide, it is only 0.5 molar sodium hydroxide. However, again, still not a very nice substance. It is very corrosive. It's very poisonous, actually, believe it or not, sodium hydroxide. Okay, and it will react with the water in the air. Again, sodium hydroxide likes to do that. It will pull water out of the air. So make sure that you have your lid on your bottle at all times so your concentration doesn't change. Okay, and this is what we have put into your
Keep the lid on.
Keep the lid on, yep, definitely. This is what we've put into your burette, and we've already cleaned and filled this burette perfectly. As you'll notice, there is still no air bubbles all the way up to the top, and we're resting on the 0 mark. Okay, the other substance we're going to be using today is an acetic acid solution of unknown concentration. Unknown being the key word here.
Unknown to them. We know.
I know. Yeah. Or we know. We know what it is. Okay, an unknown concentration. Now this concentration could be 0.001 moles per liter, or it could be 10 moles per liter. Chances are it's not, but it could be.
You didn't put just plain water in any of them, did you?
No, that would be mean.
That would be real mean.
It would take a long time for something to happen. No, but this one here, it could be any concentration. So again, if you think about your vinegar you put on your fries, that is 3% acetic acid. Okay, this is probably somewhere closer to 7 or 8, and you can imagine when you get vinegar in a cut what it feels like. So be very careful with this. You don't want to get it on your hands. Again, that's why we're wearing the gloves and the eyewear. Some of the other things you'll be using. Okay, this is your Erlenmeyer flask. Again, this is going to go, like Jeff showed you in the demo, is going to go underneath your burette. Oh. This here is phenolphthalein or phenolphthalein. Okay, this is pretty concentrated stuff. Again, it's poisonous. Okay, you want to give this a shake. Sorry, Elio, I know that's very frustrating for you. But you want to give this a shake before you use it. Okay, make sure you give it a shake, because what happens is that because it is a concentrated phenolphthalein solution, it comes out of concentration and forms a salt on the bottom. You want to get some of that salt back into solution before you start. So make sure you give that one a shake. Okay, other than that, I think we're pretty much set to go.
Okay, aren't you going to tell them what this cute thing is, or you'll do it as we do?
I can do that, yeah, as we go through it. Yeah.
So today we're doing a titration, and titration. What's a definition of a titration? We know what it is, but do we have a good definition of it?
Off the top of my head, I can think of something like the use of a known substance to find the concentration of an unknown substance.
That sounds good.
Or the use of a known concentration to find an unknown concentration.
So what we're doing is we're taking our sodium hydroxide, for which we know its concentration.
We know the concentration, yep.
And we know how to do our little stoichiometry mole ratio stuff.
Definitely.
And so we're going to be able to determine the concentration of this acetic acid.
Exactly.
All right.
I'm going to redo my definition of titration.
Oh, are you?
Because I forgot a whole bunch of stuff in there.
Okay, well, give us your revised one.
My revised.
We'll give you 3 shots at it.
We'll give you 3 shots? Okay. So titration would be the use of a stoichiometric equation and a known concentration to find an unknown concentration of a solution. Something like that.
I liked your first one better.
Yeah, I liked it better.
The second one had stoichiometric. That's a good word.
1, 2, 3. 5 syllables. I get 5 bonus points for that.
5 bonus points. All right, so let's get started. So we have already pre-put sodium hydroxide in this burette. And Scott so nicely has put the meniscus bang on 0. So we'll be able to count it. It doesn't have to be bang on 0, it just makes it easier subtracting the exact volume that you get at the end. So it's a good idea to put on 0, doesn't have to be. Now we also get to use a little tool that we haven't used before called a pipette. Pipette, the purpose for a pipette is to get exact volumes. And that's something that we've done a whole lot. We've got graduated cylinders that give us better exactness on how much volume you've got. You've all looked at your measuring cups at home and it says 1 cup, and often who knows if you're even close to 1 cup. But these things get us some real good accuracy. So we have a 25 milliliter pipette. What sizes do they come in? I've used 10s before, 25s.
Anywhere up to 50. So you can get them 5, 10, 15, 20, 25, 30, 35, 40. And we also have micro pipettes which go down to about 0.1 nanoliters.
0.1 nanoliters?
I believe that's the lowest I've seen.
That's pretty low.
Yeah, that's for things like protein separations and that kind of stuff, crystallography.
So how much would this cost?
$1,000 for that.
About $1,000.
For one of those, about $1,000.
Okay, good. Well, are you going to show us how to fill this? Maybe how to clean it first?
I will show you how to do that.
All right.
Okay, now again, like Jeff and I have just been saying, these are fairly expensive little pieces of equipment. Again, they are accurate to 0.1 milliliters, so they're extremely accurate. And you'll notice on here, they have a tip and they have a etched line that's halfway up the tube. So what happens in the lab is they make these and then they fill them with exactly 25 mils of solution. And where the meniscus rests is where they etch the line. So these are accurate, very, very accurate material. So what you're going to do, when you're not using these, make sure you clamp it into your burette stand and it'll just stay there just nice. Okay?
I'd be careful with the clamp stand because I was clamping it in one, it seemed to move on me. So be careful in clamping those that you don't drop them because they are worth $1,000.
Okay, now with this solution, okay, the unknown solution, again, we don't want to titrate it right out of the bottle because there are other people that may use this unknown, believe it or not.
Remember I showed you that in my demo, that I didn't have an extra beaker, and so I did titrate it out, or I did pipette it out of there, but I told you weren't supposed to do that, and if Scott found out, he'd get mad at me. Are you mad at me?
No, I'm okay.
You're supposed to say yes.
Okay, yeah, I am.
Okay.
Okay, so we have our little beaker here. Make sure you pour it into your 50 ml beaker. Now you're going to need at least 25 mils, so make sure you fill up your 50 ml beaker right to the 40 mark at least. Lots of people will fill it up halfway.
So we get to waste a little bit.
You get to waste a little bit, yeah. But you fill it up halfway and then you don't have enough in there. Now these are pipette pumps, okay, and they're kind of neat. You roll them up and it should suck the solution up into your pipette. However, okay, the one thing we don't like to see is people twisting and pushing these things in because obviously if these are worth $1,000, they break off. These are also worth about $1,000. So when you break them off and they get stuck in there.
They're plastic. It could only be like 500 bucks.
Okay, $500. So when they break off in there, these have to be thrown away as well. So just be careful, okay? Push them in, they have to be in there firm, but not too firm. Firm, but not too firm. So that's like slowly but quickly. Okay, and you'll notice that they stay right in the pipette pump.
Oh, gee.
Yeah, no.
It's worth $1,000.
Okay, when you pipette these, you're just going to pull solution up into the pipette. Now we want to clean it first. So once you get it about halfway.
Don't break it. Oh, about halfway.
About halfway. You just take this off, put your finger on it, okay, and tilt the pipette back and just give it a quick rinse.
Is it okay if the liquid gets on your finger?
Well, we prefer not to, so just be careful not to push the liquid too far. You should be able to turn it quite easily without getting anything on you. Okay, and then the rest of it can go down the sink.
Oh, you don't put it back in your beaker?
Definitely not, because there's contaminants already in there. So
okay.
We won't put it back in the beaker. Now, make sure that your pipette pump is all the way back to the 0. Okay, put it back on again. And now we're going to pipette
25 in there? Oh yeah,
pipette our 25 mils.
You know, we used to do this just sucking it up with our mouth.
I know, isn't that crazy?
And I saw actually somebody sucking it up with their mouth, and their pipette was a little bit above the level of the liquid, right into his mouth with hydrochloric acid.
Nice. That's
not a good thing.
It's good mouthwash. Makes your teeth white. Anyways, so we've got this up to here. Now, you'll notice, if you can see this on the video,
Oh, you
I've
went
got
past.
I've got it past the point here. Now there's a real easy way to deal with this, okay? And all you do is you press the button on the side here. Oops, that's a little quick. We'll do it another way. This is a brand new pipetter, so it makes life a little bit more difficult. What I'm going to do is just turn the wheel back the other way until I get it exactly on 25 mils.
Oh, so you can just use that wheel as opposed to using the button.
Exactly.
Okay, and
Okay.
where am I going to put that?
This goes directly into your Erlenmeyer flask.
Okay. Oh, and I get to just push
You
that
can just
thing
push
down.
that down and then it'll go all the way through. Now you'll notice that at the end you will have some fluid left in the tip of your pipette. Okay, don't worry, the pipette is calibrated so that there is fluid left in the end. So make sure that you're not trying to get this out because it's calibrated for that already, so you'll have more than 25 mils.
Ah, so you don't shake and blow and
Definitely not.
get rid of it. Okay.
Okay, now again, because these are $1,000, we're putting them back in our stand.
And when you're done with it, clean it.
Yeah, well, we're going to do 3 trials, so we'll just leave that one for now.
Okay.
But yeah, make sure you clean it after you're done your trials. Now, once you have your solution in here, you need to add 40 mils of water. Okay, so 40 milliliters of distilled water. Now, it's important to note that this doesn't have to be exactly 40 milliliters of water, but for all of our purposes, for all of our labs, we would appreciate it if you did use exactly 40 mils. Okay, so again, get your graduated cylinder out. You're going to add 40 mils of water. Now, the reason why you're adding 40 mils of water is because sodium hydroxide, when it mixes with acetic acid, produces heat, and a lot of heat. So what we want to do is we want to dilute it so that the heat production will be less. Now, you'll also notice that this 40 mils, again, it's not exactly 40 mils, it's close, but I'm not changing the number of moles of solution that I put in here. I'm only changing the concentration. Okay, that's important to note because when you do your calculations in the end, you still have the same number of moles of solution in that Erlenmeyer flask.
I'm with you. I'm with you. So, yeah, in the demo that I did in the class the other day, we didn't add the extra 40.
Oh, you didn't?
My beaker didn't blow up on me, fortunately.
Fortunately, yeah.
Fortunately. I
Gets-
went slowly.
Gets a little warm.
But this does change the concentration of it now. So we're changing the concentration fairly dramatically of the liquid that's in there. But as Scott says, the number of moles of acetic acid hasn't changed. And that's what we're titrating against, is how many moles of this stuff react with moles of that stuff.
Exactly. That's why we have our balanced equation. Now our phenolphthalein, or phenolphthalein, people will call it different things. Okay, this stuff is actually ultra sensitive, and it changes at a pH of roughly 8.5 or 9, so as soon as your solution turns basic, this stuff will turn on you. You're going to add 4 or 5 drops. I believe the lab says 2 or 3, but let's add 4 or 5 just for fun. Okay? And what you're going to do is you're going to start titrating. Now, the way you titrate, okay, the way you're going to titrate is one hand is the stop and go, the other hand is the stir. So you're going to start titrating, and it's going to be a stop and go. So put in about 2 or 3 mils and stop, and then wait for your pink in your solution to go away. Okay?
Oh, so it's turning pink.
It turns pink.
I
yeah.
didn't see that. Your hand was right in the way.
I know, it's one of those things.
Oh, I see pink there.
So we're going to keep on titrating until the pink starts to stay in solution. So it's going to start to stay in solution, hopefully with this one, about 10. If I did my measurements correctly.
But you don't want to get too close. What are you at now?
I'm just at 10. Now once I start getting the pinks to stay in solution, okay, it's going to go away slowly or quickly at first, and then slowly and more slowly towards the end. Once you get to that, you can control these burettes so that you're only doing about a drop at a time. And again, I know what the concentration is here, so I'm able to go a little bit more quickly than you guys will be able to.
Still clear.
Still clear, so we're just going to add drop by drop.
So you have to be mixing it the whole time. You can't just sort of put in 3 or 4.
Well, you can, but then you don't get the exact reading that you want. So I prefer to keep mixing the whole way through.
So now what do students do? Like you sort of have a ballpark idea of what the concentration of the unknown was. And we did that purposely for the video. Whoa. I think you were a little quick there.
A little quick, but about right.
So what do students do if they don't know what the concentration is going to
You
be?
have to go slowly.
Slowly.
Yeah, so you have to do these trials. There's only 3 trials you get to do, and your unknown only contains 100 milliliters of solution. So really, you only get 3 trials to make this work. Okay, so make sure that you go do this slowly. You end up with a solution that looks pink, and this is a little bit too dark. You want a little lighter pink than this. I went a little too far on my titration, which I guess that's about right. Okay, so this is a little bit too far. So you want to go a little bit less pink than this, but your solution will turn pink when you're done your titration, and that'll indicate your end point. From there, you're going to take your concentration and your volume, find out your number of moles, use your stoichiometric equation or your balanced equation, find the number of moles of acid in your solution, and then divide that by the volume of acid to find your concentration of your acid. And that's the long and short of this lab. Actually, more like the long of this lab.
That sounds good. So just a quick little wrap up then. We're titrating sodium hydroxide that was in our burette with acetic acid that we measured with our pipette, put it into our Erlenmeyer flask, and we went slowly. Ours was fairly quick because Scott knew exactly how many mils he should put in. But you want to go slow. And just notice as you're putting stuff in, if the color goes away immediately, you know you need quite a little bit more. And if it's taken a little bit longer for that color to go away, you're getting closer to your end point. So slow down, drop by drop. That's it. Any parting shots?
No, I don't think so. Not today.
Okay, so we do this 3 times, and it says in the lab you have to be close within a certain amount. So make sure you do that, and you just take your average of those 3 calculations.
Perfect.
All right, thanks.